In 1981, the Soviet Union secretly launched a machine that made every warship afloat look small. It was a nuclear submarine as massive as a battleship, so wide it could carry dual hulls and up to 200 nuclear warheads beneath the Arctic ice. Built not for stealth but for overwhelming second strike power, the Typhoon class turned Cold War logic on its head and forced the world's navies to confront something no one thought possible. But what drove the Soviets to build something so absurdly big, and what price did they pay for it? Soviet naval planners faced a problem that kept them awake at night: how to guarantee a nuclear strike even if the first blow came from the enemy. In the world of Cold War strategy, survival meant more than stealth. It meant redundancy, endurance, and the ability to strike back no matter what. The Soviet Union's answer was to build submarines so large, so resilient, that not even a direct hit could silence them. Bigger wasn't just better, it was essential for survival. By the late 1970s, American Ohio-class submarines were entering service, each carrying 24 Trident missiles and threatening to tip the balance of power. The Soviets needed a response that would not only match, but outlast any Western rival. Their doctrine called for a second strike force, submarines that could hide beneath the Arctic ice, wait out an attack, and then respond with overwhelming force. Size was the key. Only a giant could carry the R-39 missiles, each heavier and longer than anything the US deployed. Only a giant could house enough crew, supplies, and duplicated systems to survive months under ice, isolated from the world. The Kremlin authorized 6 Typhoon-class hulls, starting with TK-208 in 1981. Each one was a floating fortress, designed less like a submarine and more like an insurance policy for the Soviet state. The dual-hull layout, massive internal volume, and sheer scale weren't excess. They were a calculated answer to the terrifying logic of nuclear war. In this world, bigger meant safer, and safety meant the difference between annihilation and survival. The numbers alone strain belief. At 175 meters in length, the Typhoon-class submarine stretches farther than a city block, longer than most football fields, and nearly the size of 2 Boeing 747s parked nose to tail. Its beam, 23 meters across, makes it as wide as a 4-lane highway. Submerged, the Typhoon displaces a staggering 48,000 tons of water. That's more than twice the weight of a typical World War II cruiser, and it rivals the full load of the mighty Iowa-class battleships. This is a vessel that outweighs every destroyer and cruiser ever built. Only a handful of the world's largest aircraft carriers and battleships have ever matched its mass. When underwater, the Typhoon is not simply a submarine, it's a capital ship, moving unseen beneath the waves. For comparison, the American Ohio class, itself considered enormous, measures 170 meters in length and 13 meters across the beam. The Typhoon dwarfs it, not just in width, but in overall volume. Its internal space could swallow a small surface warship. The size wasn't a luxury, it was a necessity, dictated by the demands of its mission and the bulk of the R-39 missiles it was built to carry. Every meter of this submarine served a purpose, from housing vast missile silos to providing enough room for crew, supplies, and the duplicated systems that made it so resilient. The Typhoon wasn't just large by submarine standards, it was large by any standard, a steel leviathan designed to endure and to intimidate. Designing the Typhoon-class submarine meant throwing out the rulebook. Instead of one long pressure hull, Soviet engineers at the Rubin Design Bureau built 2 enormous cylinders side by side, each nearly 10 meters in diameter, joined by a network of smaller hulls and passageways. On paper, it looked like a catamaran. Underwater, it was something entirely new, 5 interlinked pressure hulls encased in a single outer shell. This radical approach gave the Typhoon its extraordinary width and internal volume, turning the submarine into a kind of floating fortress. The dual main hulls ran parallel for almost the entire length of the boat, each housing its own set of critical systems, reactors, turbines, and crew quarters. If one hull was breached, the other could still function, giving the crew a fighting chance in the event of disaster. Between these giants, engineers carved out space for the Typhoon's arsenal, slotting missile silos in the gap, safely isolated from living quarters and machinery. 3 smaller hulls, the forward torpedo section, a central command module beneath the sail, and a rear steering compartment, completed the 5-hull network, all connected by pressure-locked tunnels. This structure was not just about size, it was about survivability and redundancy. The Typhoon could lose a section and keep going. Compartments could be sealed off in an emergency, and duplicated systems meant no single hit would doom the entire submarine. The result was a machine that felt less like a boat and more like a mobile undersea base, a triumph of engineering audacity from the Rubin Design Bureau and the ship builders at Sevmash. Hidden beneath Arctic ice, the Typhoon-class submarine carried a nuclear arsenal that bordered on the unbelievable. 20 R-39 intercontinental ballistic missiles stood ready in their silos, each one stretching over 16 meters and weighing nearly 90 tons. These missiles weren't just big, they were designed to deliver devastation on a scale few machines in history could match. Each R-39 could travel more than 8,300 kilometers, crossing continents to reach its target. Inside every missile, 10 independently targeted warheads waited, bringing the total potential to 200 nuclear warheads on a single patrol. This concentration of power was not just for show. Cold launch technology allowed the Typhoon to fire its missiles while submerged, even when sealed beneath 2 meters of solid Arctic ice. A compressed gas charge would hurl the missile out of its flooded silo, breaking through the frozen roof above. Only after clearing the water and ice would the rocket ignite, sending its deadly cargo toward distant shores. Operating under the polar cap offered a sanctuary no enemy could easily penetrate. The ice shielded the Typhoon from satellites and sonar, turning the Arctic into a fortress. From these hidden positions, the submarine could wait, silent, undetected, and ready to unleash destruction if the order ever came. For the crew, this was both a burden and a shield. Their vessel was not just a war machine, but the final guarantee of their country's survival. Life inside the Typhoon-class submarine was nothing like the cramped, Spartan world most people imagine beneath the waves. With a crew of roughly 160, the designers made endurance a priority, knowing these men would spend up to 120 days sealed away under the Arctic ice. The Typhoon carried enough food and fresh water to last for months. But survival meant more than rations. It meant keeping minds steady and morale intact in a world without sunlight or escape. Inside its enormous hull, the Typhoon offered comforts unheard of in any other submarine: a sauna, a gym, a swimming pool, even a solarium lit by artificial sun lamps. Crew members could unwind after a shift, sweat out stress, or gather in common rooms that felt closer to a college dorm than a war machine. Living and working spaces were separated, easing the relentless pressure of alert duty. These small luxuries became lifelines, breaking the monotony and tension of patrol. In a vessel built for apocalypse, the human element was never an afterthought. For those on board, each day was a test of patience, routine, and the quiet hope that their mission would remain only a deterrent, never an order to launch. By the early 1990s, the world that created the Typhoon had vanished almost overnight. The Soviet Union collapsed in 1991, and with it went the steady flow of money and resources that kept these giants at sea. The Typhoon's enormous crew, constant maintenance, and specialized Arctic support bases became impossible to justify in a new era of shrinking budgets. Each patrol cost millions, and the submarines required a small army of technicians just to stay operational. Arms reduction treaties like START 1 and START 2 targeted the very heart of the Typhoon's mission. Their massive R-39 missiles, once a symbol of Soviet strength, were now liabilities, too large, too expensive, and suddenly illegal under new agreements. By the mid-1990s, most Typhoons sat idle at their piers, their missile silos empty, waiting for a purpose that never returned. Naval planners turned to smaller, quieter designs. The focus shifted to stealth, automation, and efficiency, qualities the Typhoon, with its Cold War DNA, could never match. Decommissioning began in earnest. Hull after hull was scrapped, often with American funding, as Russia redefined its nuclear deterrent for a world that no longer had room for excess on this scale. The era of the super submarine ended not with enemy action, but with the slow grind of economics and treaties. No military today builds machines this massive, because the world now values stealth over spectacle. Yet, as new arms races simmer under the Arctic and beneath the seas, the Typhoon's legacy warns us technology alone never guarantees security. The next era of deterrence is already quietly taking shape. What is your take?